In this video, we're going to see how we can use electrode potential values to predict if a reaction will happen or not. So what we've got on in this diagram here is we've got the zinc electrode on the left hand side. So we've got the zinc metal in zinc 2+, and on the right hand side we've got copper metal in copper 2+ ion solution. Right, we wouldn't normally write it, draw the whole diagram. We'd use this here, which is the cell diagram, a much quicker way of showing it the conventional way. Now, if we have a look at this table over here, right, I've got the two electrode potential values here. I've got them from this table over here, right? So you've got a table, a whole load of them there, right? Just to show you where they are. There's the copper one, copper 2+ and 2 electrons plus 0.34 volts, and the zinc one is down here minus 0.76 volts. So what all of those voltages mean is that's what the voltage of the cell would be if you connected that half cell to the hydrogen half cell, which is the sort of reference electrode. Okay, so that's what they all are. Now let's go back to this diagram over here. Right, I've just written down the electrode potentials again. Now, if we want to work out the voltage of that cell, E cell, so what would be the voltage? What would be the reading on this voltmeter up here if you did this? Right, what we do is we say E cell is equal to the electrode potential of the right hand side, electrode potential of the left hand side. So the right hand side is 0.34, electrode minus 0.71 for the zinc, 76, sorry, not 71. 76. So then what it would be is that would be the E cell would be plus 1.10 volts. So the reading on this voltmeter would be 1.10 volts, and it's positive, and so that means the copper is the right hand side. Okay, so that's what that means. Now let's see how we can use it to predict this direction of reaction. So I'll just rub that out. Now if we look at those two half cells, let's think about which one is best at pushing away electrons. Right, now the one that's best at pushing away the electrons is the negative one. It's this one here, the most negative, because the electrons are negative. So if it's negative, it's going to be pushing away from it. And now if it's pushing away electrons, that means the zinc is going to be turning into Zn2+. It's going to be pushing away these two electrons, and those two electrons are going to go up the wire here. Yeah. And then we think the copper one, which is the most positive one, well, it's obviously the other one, the copper. And that would be the best at sucking in electrons. Positive, it's going to attract negative electrons. So this is going to suck in electrons. So that means this one is going to go forwards. So, the electrons are going to go around there. Now, so we've got these two half equations here, and we can see which one's going forwards and which one's going backwards. So we can write a balanced equation. So the balanced equation would be there, Zn plus Cu2+ goes to Zn2+ and Cu. So the question, if somebody asks you a question, will zinc react with copper sulfate? You know it will anyway, but yes, it will, because we've just shown it will there, because the zinc, those electrode potentials show us the direction in which the electrons are going to flow from the negative half cell to the positive half cell, and from that we can work out what the reaction is going to be. Right, we're going to use that now to answer some more questions. Okay, so we go over to our values. We've got our big table of electrode potentials there. Right, I'm going to zoom in a little bit around. So we want this part of it. Okay, now the question is, and you probably know the answer to this question already. You would certainly know the answer to it when you're in year 9 or something. Like, the question is, will copper dissolve in hydrochloric acid? Okay, so which two half cells are we going to be interested in there? Well, we are going to be interested in the one with H+, because they're in acid, so we've got that one. and we'd be interested in this this one here, copper metal. Okay, right. So now let's have a think about those two. Which one of those two? And probably a good idea if I write them down here. So we're going to have so copper 2 plus 2e minus goes to Cu, and 2H plus 2e minus goes to H2. And the electrode potentials there are plus 0.34 and 0. Okay, which is the most positive out of that one? Right, it's this one, the copper one, isn't it? So that's going to be best at sucking in electrons and take in those electrons. So that one would go forward. Which is the most negative? It's the hydrogen, because that's 0. That's going to be the best at pushing away electrons. So the answer there is, right, hydrogen will react with copper. Let's combine those, write the equation. Okay, so we're going to have H2 plus Cu2 plus is going to go to copper metal and 2H plus. Well, is that what the question's asking? Will copper dissolve in HCl? Well, no, it won't, because that's the exact opposite of what will happen. Copper will not react with H plus. Actually, copper 2 plus will if you react with hydrogen, will form copper metal and hydrogen ions. So the answer to that is no, that reaction will not happen. So we've used it to predict, to show us that copper will not react with acid. We've done that by like sort of showing the opposite will happen, the exact opposite of what we are saying actually what we're asking happens. Incidentally, this tells you that that reaction is possible. If you bubble hydrogen through copper sulfate solution, actually nothing will happen because the rate of reaction is too slow. Unless you had something like a platinum catalyst in there or something, then it would happen. So it's important to realize these electrode potential values don't tell you anything about the rate of reaction. They just tell you, is the reaction possible, thermodynamically possible. If you've done delta G already, basically it means is delta G for that reaction negative. If you haven't done delta G, don't worry about it. Right, let's ask another question then, another one. So another example. Right, let's have will iodine let's have will zinc react with hydrochloric acid? Okay, so if we have a look at our values of tables here, we've got our zinc one there. Look, here's zinc minus 0.76 and hydrogen is 0. So right, let's do it on here. So let's have a look at those. Which is our, I'll do it in yellow. Which ones are we interested in? Well, we want the hydrogen ion one, yeah, that one, and we want the zinc one, that one, minus 0.76. Which is the most negative out of those? It's the zinc one, so that's going to be best at pushing away electrons. So that means the zinc is going to go backwards. Okay, so this one is going to go backwards. And which one's going to go forwards? Well, the hydrogen one's going to go forwards. Why is that? Because that is the most positive one. So that's going to be sucking in negative electrons. And see, it's getting those 2 electrons there, sucking them in. So if we write down what is the overall reaction there, we can see. So the zinc one goes backwards. So that's going to be Zn. Hydrogen one goes forwards. So that's plus 2H plus. Goes to zinc and H2 gas. So the answer to our question, will zinc react with acid, HCl? Yes, it will, and it will make Zn2 plus ions, and it will make hydrogen gas. So the piece of zinc will fizz up and make hydrogen gas. So we've answered that one. You probably knew that what happened anyway. So let's try one that you probably don't know, a reaction. The question is here is right. The question is, I'll just get to the right bit of the, I'm going to need you. Okay. All right, I need to be up here. The question is, will will Fe3 plus ions react with iodide ions? Okay, so if I got a beaker of, say, iron 3 chloride and potassium iodide, would there be any reaction? Let's have a look. So we need this half equation. This has got Fe3 plus in it. And we need this half equation that's got I2, iodine in it. Okay, iodine and iodide, okay. Which is the most positive out of those? Well, it is the iron one. So that will suck in the electrons. So that one's going to go forwards. Which is the most negative? It's the iodine one. So that's going to be pushing away electrons. So that's going to make those electrons and go backwards. So if we write down the overall equation for that, well, we're going to have to multiply that one by 2, because that's only one electron. This one has got 2 electrons in it. So the equation there would be 2I minus plus 2Fe3 plus goes to I2 and 2Fe2 plus. So you can see the iodide ions would reduce the Fe3 plus ions to Fe2, so they would react. So that's why it's impossible to have a solution of iron 3 iodide. You can't have it because it would react. The ions would react with themselves. You get some iodine produced, and you turn into Fe2 plus. Okay, so we've successfully seen that one can react there. Now, before we finish up here, let's have a look at this table as a whole, right? And we've got them all in order here, and this is called an electrochemical series. When you put them in order like this, and beware, because sometimes in exam questions they put the most positive at the top and work downwards. Other times they put the most negative at the top, so look which way around it is. Right, this is an electrochemical series, so they're all in order. Now, which one is best at accepting electrons? Which side accepts electrons, first of all? Right, this side accepts electrons, and this side, if it goes backwards, they're going to give away. All the species in that right-hand column give away. What kind of things give away electrons? Well, they are reducing agents. What things that accept electrons, what are they? They're oxidizing agents. Right, which is the best oxidizing agent of that list there? Well, the best oxidizing agent is going to be the one that's most positive, because that's going to be really good at pulling electrons. So you can see it's the fluorine. Fluorine is the strongest oxidizing agent in that list there. So I'm going to put there increasing strength of oxidizing agent. They get stronger. Okay, so fluorine is just about the best oxidizing agent you can have. And look at the you've got a nice little trend down the halogens there. Fluorine is better than chlorine, which is better than bromine, which is better than iodine, which is right down there. We know that already, so it just confirms what we know. Right, these on this side, these are all reducing agents. So which one is the best reducing agent? Well, it's the one that is the most negative. And so it's the best one, the most negative, potassium. That's a very good reducing agent. We know that. Potassium loves losing electrons. It gives them away to things. So you've got the best reducing agent. Right, and that table is very useful. We can see we've got a list of oxidizing agents on the left, and they're in order of strength, and we've got reducing agents on the right, and the best ones are towards the bottom there. Okay, so we're going to use those electrochemical series to predict the direction of reactions.